Binary sequence types bytes, byte array, memory view. The core built in types for manipulating binary data are bytes and byte array. They are supported by memory view, which uses the buffer protocol to access the memory of other binary objects without needing to make a copy. The array module supports efficient storage of basic data types like 32-bit integers and IEEE 754 double precision floating point values. Byte objects. Byte objects are immutable sequences of single bytes. Since many major binary protocols are based on the ASCII text encoding, Bytes objects offer several methods that are only valid when working with ASCII compatible data and are closely related to string objects in a variety of other ways. Class bytes, source encoding errors. Firstly, the syntax for bytes literals is largely the same as that for string literals, except that a B prefix is added. Single quotes. B still allows embedded double quotes. B double inverted comma still allows embedded single quotes. Triple quotes. B triple quote, three single quotes, end of triple quotes. B triple quotes, double string code, three double quotes, end of triple quotes. Only ASCII characters are permitted in bytes literals, regardless of the declared source code encoding. Any binary values over 127 must be entered into bytes literals using the appropriate escape sequence. As with string literals, bytes literals may also use a R prefix to disable processing of escape sequences. See string and byte literals for more about the various forms of bytes literal, including supported escape sequences. While bytes literals and representations are based on ASCII text, bytes objects actually behave like immutable sequences of integers, with each value in the sequence restricted such that 0 less than equal to x less than equal to 256. Attempts to violate this restriction will trigger value error. This is done deliberately to emphasize that while many binary formats include ASCII based elements and can be usefully manipulated with some text oriented algorithms. This is not generally the case for arbitrary binary data. Blindly applying text processing algorithms to binary data formats that are not ASCII compatible will usually lead to data corruption. In addition to the literal forms, bytes objects can be created in a variety of other ways. A zero filled bytes object of a specified length, bytes 10, from an iterable of integers, bytes range 20, copying existing binary data via the buffer protocol, bytes object. Also see bytes built in. See, two hexadecimal digits correspond precisely to a single byte. Hexadecimal numbers are commonly used format for describing binary data. Accordingly, the bytes type has an additional class method to read data in that format. That class method is from hex string. This bytes class method returns a bytes object decoding the given string object. The string must contain two hexadecimal digits per byte, with ASCII white space being ignored. For example, let's see the example. Print and print. Bytes dot from hex. This one is the hex value, and if I print, it will print like this. If you want to, change it in version 3.7, bytes dot from hex now skips all ASCII white space in the string, not just spaces. A reverse conversion function exists to transform a bytes object into a hexadecimal representation. Hex sep, comma, bytes per sep separator. Return a string object containing two hexadecimal digits for each byte in the instance. If I try to execute this statement, bytes, these are bytes xf0, xf1, xf2 dot hex, it will print the hex value f0, f1, f2. If you want to make the hex string easier to read, you can specify a string character separator sep parameter to include in the output. By default, this separator will be included between each byte. A second optional bytes per sep parameter controls the spacing. Positive values calculate the separator position from the right, negative values from the left. Value is equal to this, value is equal to this. Okay, value is equal to this, and then print value hex minus, print value hex minus, it will print its value, hex value, and then underscore, it will print f0 underscore f1 f2, and this uuddrlr dot hex minus 4, it will print like this. New changed in version 3.8, bytes.hex now supports optional sep and bytes per sep parameters to insert separators between bytes in the hex output. Since bytes objects are sequences of integers akin to a tuple, for a bytes object b0 will be an integer while b01 will be a bytes object of length 1. This contrasts with text strings where both indexing and slicing will produce a string of length 1. The representation of bytes objects uses the literal format b dot 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 since it is often more useful than example bytes 46 46 46. You can always convert a bytes object into a list of integers using list b. Thank you.